Okay, let's take the greatest common factor out of polynomials. First of all, remember that the word factor means to multiply. So factors of 10, for example, are 2 times 5 or 1 times 10. So with that in mind, if I had an expression 6x plus 9, what I need you to find is the factor that's common to both of those terms or divides into both of those terms equally. In this case, it's a 3. So I want you to factor out that 3, and now I need you to think about the distributive property. What do I need to put right there so that when I multiply it by 3, I get this 6x? And I need a 2x there, again, because 3 times 2x is 6x. Now what do I need to put over here so that when I multiply it by the 3, I get the positive 9 that I began with? You should always be able to go back and check these, multiply, and see if they give you your original expression. I've taken the greatest common factor of 3 out of 6x plus 9. Similarly, 5x minus 10. The greatest common factor is 5, so I'm going to factor that out. I'll open up my parentheses, and I'll ask myself, what do I need to put here so that when I multiply it by 5, I get 5x? And then what do I need to put over here so that when I multiply it by 10, I get this, when I multiply it by 5, I get a minus 10. I'll need a minus 2 there. Again, distribute it, check it. 5 times x is 5x. 5 times a minus 2 is a minus 10. If I have an expression where the variable occurs in both of the terms, remember that the greatest common factor is the variable raised to the smallest power. So while I have a common factor of 8 in each of these terms, I also have a common factor of y. I can take no more than y out of each one of these terms. Again, I use the smallest exponent. And once I've decided that that's the greatest common factor, next I'll decide what I need inside the parentheses so that I can distribute it and get what I started with. So I'll need a y here because 8 times y is 8y squared. And I'll need a minus 3 here because 8y times a minus 3 is a minus 24. Continuing the topic of taking the greatest common factor out of a polynomial, when an expression such as this has a greatest common factor of numerical value of 4 and a variable of x, be sure then when you write inside the parentheses that you need a 3x as the first term, because 4x times 3x is 12x squared. Be sure to put a 1 right here, because when you multiply 4x by 1, you'll get that second term. That 1's got to be there. Some people often want to leave that out. So, in a problem like 9y to the 4th plus 6y cubed minus 3y squared, the greatest common numerical factor, the number that divides into each of these evenly, is a 3. The variable y occurs in every one of them. I can only take it out to the smallest power. And so, in parentheses here, I'll need a 3y to the second power because that product right there, remember that when you multiply, of course the 3 times 3 is 9. Y to the second times y to the second is y to the fourth because you're adding those exponents when you multiply. I'm going to need a 2y as my second term because 3y squared times 2y is 6y to the third power. And again, don't forget that 1. Finally, again, we're talking about taking the greatest common factors out of polynomials. If I had an expression like this, you'd have to look at that and say there is no common numerical factor in the 7 and the 3, and there's no common variable. And so we would say that it's prime, or we might say that it's already factored, because its only factor that you can pull out of each of those terms is a 1. Basically, we do nothing with this expression. We're going to go on to the next topic.